So for this chapter, we have two big ideas, and this is big idea number one, conservation of energy. So you already defined these terms and found their units, and if you did not, you need to pause this video right now and go do that, because the rest of this isn't going to make any sense unless you have this. So conservation of energy tells us that the total energy in a system is constant, meaning that energy may neither be created nor destroyed. The law of conservation of energy, just like the law of conservation of matter from chemistry. So in order to do anything, we need to identify the types of forces or the types of energy present in our system. And in order to do that, we need to ask ourselves three main questions. Is it moving? Is it above a zero height, or is it stretched or compressed? If it is moving, it has kinetic energy. If it's above a zero height, it has gravitational potential energy. And if it is stretched or compressed, it has elastic potential energy. And so we need to identify those types of energy before we can try to figure out and solve any of our problems. So here's Miss Mac. She's holding a book up in the air, and the top pink line here is just showing us how high she's holding it, and this bottom pink line here is the ground. Okay? So we ask ourselves the questions. Is it above the ground? Yes, it is above the ground. So since it's above the ground, it has gravitational potential energy. Okay? Is it moving? No, I'm holding it above my head, so it's not moving. Is it stretched or compressed? No. No, it's not a spring or anything like that, not a rubber band. It's not stretched or compressed. So I'm just holding it up. So all the energy it has at the top is gravitational potential energy. And then Miss Mac takes this book and she lets it go. Boing! Okay? So what happens? The book's falling. As it's falling, let's say we got this point here partway through. Is it above the ground? Yes. So it has gravitational potential energy. Does it have as much gravitational potential energy as it did? No, because it's not as high. You want to be high. The higher up you are, the more gravitational potential energy you have. Okay? So it has gravitational potential energy. Is it moving? Yes. It's starting to fall, so it's got a velocity. So it also has kinetic energy, and it's still the book, and it's not a spring, so it's not going anywhere. Now, here's what happens. Conservation of energy says that the total energy is the same no matter what. So my gravitational potential energy at the top is equal to the sum of my gravitational and potential and kinetic energy in the middle, and anywhere in the middle. And then as my book falls, we grabbed the wrong thing, falls, it's getting faster and faster and faster. So here it's going really fast, and since it's going fast, it has more kinetic energy, but it's not very high above the ground, so it has less GPE, gravitational potential energy. But again, the sum of these two the sum of these two forces or energies added together is the same as our gravitational potential energy at the very top. And then once our book gets that nano hair above, that little nanometer above the ground, so it's not like stopped on the ground, all of that gravitational potential energy has been changed into kinetic energy. So we have kinetic energy only. But again, the kinetic energy here is equal to the gravitational potential energy here is equal to the sum of the different energies here. So we had to identify the type of energy present to figure this out. Now here's what happens. If I drop this book, you will find that it will eventually stop. Okay? So now my book is actually resting on the ground. So as my book is resting on the ground, is it moving? No. Is it above the ground? No. Is it stretched or compressed? No. Seems like we've lost energy, doesn't it? But we haven't. You have to be really careful here, because what's happened now, did you hear something as the book hit the ground? There was sound. There's sound waves coming off. And that sound is a form of energy also. It's non-mechanical energy. It's not useful energy. There's also vibrations. If I had to drop the book right at your feet, and you can do this at home, just take a big old fatty heavy book and drop it from a high up space, and you can actually feel the vibrations in your feet. That's also not useful energy, so it's non-mechanical. So our mechanical energy is our gravitational and our kinetic, which is useful energy, whereas our sound and our vibration and any heat generated, that is not useful energy. And so it's there, but it's just not usable. But the amount of sound and vibration energy and heat energy generated is equal to this gravitational potential energy that we had at the top. Okay, so once again, our three main questions. And this is a picture of a roller coaster. There are some roller coasters that actually launch their cars by using a compressed spring. So here we have a spring that's compressed. And so what kind of energy do we have here? We have elastic potential energy. Are we above the ground? No, not really. We can set our 0 point wherever we want to set our 0 point. So even if this was raised up on tracks and up above the ground, we can set where its starting position at our 0 point. So it has no gravitational potential energy. And is it moving yet? The answer is no. But once it's been launched, so just a little bit further down the road, okay, is our spring compressed anymore? No. So we don't have elastic potential energy anymore. Are we moving? Yes, we are. We are moving, so we have kinetic energy. Are we above the ground? No, we're still at that 0 point. So all of that elastic potential energy that we started with got changed into kinetic energy. Then a little bit further along the road, let's say we're here at the top of the loop. We went through the loop. Okay. Are we moving? Well, I hope so, or we're going to fall. So yes, we're moving. And we have kinetic energy. Are we above the ground? Yes. So we have gravitational potential energy. Do we have a spring that's just stretched or compressed? No, we don't. So we don't have elastic potential energy. So when we add these two together should equal that elastic potential energy we started with. So when we add these two together, we end up with the energy that we started with. And then up here at the very, very, very top, here's our car. You notice a lot of times when you go through a roller coaster, there'll be this highest point where you kind of stop and hover. So are we moving now? Nope. So we have no kinetic energy. Are we above the ground? You bet we are. So we have just gravitational potential energy. And are we stretched or compressed? Nope. So this gravitational potential energy that we have at the very top is the same as that elastic potential energy that we had at the bottom, the same as this kinetic energy we had here, and it's the same as the sum of these two that we had in the middle. If we were to take our little car and put it here, this would be the same situation as what we had right there, because we're still moving, so we're going up the ramp, so we're moving, so we have kinetic, we're above the ground, we have a height here, and so we have gravitational potential energy. And again, all of those together are all the same number.